Hey, jom.
Let's Sembang AIoT.
So today is our 18th, our 18th session already. So okay, my name is Kenneth.
Hi, Cecily.
Okay, so today, as usual, we will talk about some AI and IoT stuff. But today I will start first. So it's different from previous. So usually it's Cecily start first. So today the topic, this is our part 2. So there is some, we continue from our last week.
Our first part is what? IIoT Sensors to Cloud. This is IIoT Sensors to Cloud, part 2.
Yeah, today is part 2. So for my AI part, last week I talked about the data set. And then this week I missed some part after I talked to ChatGPT.
Okay.
After I talked to ChatGPT, I realized I missed some part. Because last week I just based on my memories and I share something with you guys. So this week I checked with the ChatGPT and I realized I forgot one thing. It's quite important, data augmentation. So this is something very useful when you have limited sample in your data set. So when your data set is not large enough, so you need the data augmentation. So it's a technique to increase your data set size.
Wait. Data augmentation, I thought last 2 years when we started doing some training, when you conduct some training. So the augmentation is also part of the AIS, right?
Yes.
Is it that augmentation that you're referring to?
Yes.
Oh, okay.
Yeah, actually, I think all the deep learning framework, they provide the function for you to do the data augmentation. So you no need to write the code by yourself again. And then, the AIS have the built-in feature. So actually, you no need to, you need to write any code. So you just need to set the number of augmentation. So you want to augment your data how many times. That you increase your data set size. So one of the reasons we do the data augmentation is because nowadays the neural network, the number of parameters inside the neural network is getting larger. So it's already up to few millions already. So when you have few millions of parameters in your neural network, but your data set is just few hundred images, so you cannot fill in all the parameters. So some of the parameter is not holding any feature in your data set. So it will be wasted. And all these wasted parameter, it might contribute to some false detection when you run your inference. So we need to increase the data set size so that your AI can perform better. So what the data augmentation do is it will rotate your image, then it becomes a new image. So rotation is one of the technique, rotation, and then it can crop, and then this one is for computer vision. For computer vision field, rotate the image, crop the image, change the brightness, change the saturation, change the color from RGB become BGR, so the color change. And then we also can add some noise, the Gaussian noise, make the image become blur a bit, and then change the sharpness. What else we have? Scaling, you can zoom in or zoom out. Usually you zoom in. If you do the zoom out, you need to add some padding, maybe the surrounding of your image, you can add some padding. Usually we add maybe it's the black color or the white color or any color also can, just to make your object become smaller when you zoom out. So all these things will help the AI to prevent it to overfit. We want to prevent the overfit happen.
Okay, just to understand, because just for your information, those who are following us, you are watching the last Sembang AIoT session number 18, number 18. Support us, So whoever who see this, you Chinese are support, you'll be prosperous very soon, will be prosperous very soon. Talking about AIS, you see when we started this AI, because this morning also I talked to one of the I'm doing a presentation to one of the client, on this AIS thing. From day one, I think in 2019, this AIS was started by, I think Intel, basically Intel, because the whole engine is running on OpenVINO. Of course, with the ExonTech Taipei, they have developed something that make up a whole AI suite. So after coming to Malaysia, we use that to, use it in one of the what they call the training program. One of the this is Malaysia MPC. MPC organizes a program, and that was used in the whole training on the AIS. AI, basically computer vision AI. So coming to here, we have improved several what they call in terms of functionality. We have made it more easier to connect, even able to integrate to SCADA. So we always heard about this augmentation during the time. Yeah. So is this augmentation by itself already inside the AIS?
Yeah, by itself it's already inside.
Is it part of the what they call TensorFlow features inside?
Yes.
Or it's part of the TensorFlow. Those who know, when you do the AI, TensorFlow is one of the CNN framework, is it?
Yeah.
It's a convolution framework. So that is already inside the TensorFlow.
Yes.
So that means the new version will have more kind of augmentation features.
Yeah, definitely.
Oh, okay. That's okay. Thanks.
Yeah, the one in the AIS by default contain 4 types of augmentation technique. So if you come attend our training, I will tell you how to add extra more.
Okay.
Okay, so just now we talked about the data augmentation for the computer vision side. So dealing with all the images. So if we
have we have our this supporter friend, the best. You are always the best. Jin, new. You are always the best for Hexa IoT. Yeah. Okay.
Okay. So for the like the natural language processing, so if you are dealing with the audio, that kind of thing, so how you do the data augmentation is you can you have the sound clip, you have your soundtrack, so you can click the part of it, remove it, or you can when during the play the video, play the sound, play the audio, you can faster it or slow it down. So all these things you can generate more data for your AI to learn. And then, okay, if you want to train the model like the large language model, for example, the ChatGPT or the Llama 2, so the data set you provide, okay, one of the technique is you remove some of the word in the sentence, so that when the user enter the input, if forgot enter the O or A or certain words, your AI is still able to understand what the user tried to deliver. So this is one of the way we train the large language model.
But I think the large language model, talking about handling this part of thing, I think it's very, very powerful.
Yeah.
Because I saw someone, actually, I saw my son. So he's writing broken English, so the ChatGPT also is able to reply him. So, I mean, that is a very, very,
yeah. So they also use the same technique. I think they must using this kind of technique when they're during the training process. So they randomly remove certain words in the sentence or in the question and the answer. then they let the AI to learn.
That should be the unsupervised learning, unsupervised deep learning already, is it?
Yeah, for the ChatGPT, they combine both supervised and unsupervised. So they have both techniques to train.
Otherwise, they are not able to achieve, by removing this one and that, should be the part of the unsupervised as well.
It contains the supervised and unsupervised.
Yeah, of course, there are supervised ingredient inside. Okay.
Yeah, so I think I've really covered for the computer vision, the image, and then for the natural language processing, the audio, and then also for the large language model. And I think for the last few sessions, we did talk about the workspace safety.
That was in session number what? What was the stage? What was the session? We show the facial recognition part. Yeah. So we actually owe the audience the workspace AI vision. There are some requests from the audience. Hey, are you able to demonstrate to us? Yes, today. It's bringing up to you how to do this. Demonstrate this one to you. It's on the 12th. You can watch back our 12th session.
So number 12, we only demonstrate the facial recognition. So facial recognition is one of that. Another one, today what we want to demo is the one we want to apply at the construction site. So it will related to the personal protective equipment. For example, the helmet, the vest. So these two is the most common one. If you also want to detect the boot and the glove, also can. But most of the time, these two things is too tiny. It's too hard to receive. So it's very challenging. And at the construction site, usually it's not easy to set up a CCTV permanent there to monitor your worker, how they do the work. Because construction site, every day, the building is keep changing. It's getting taller, getting bigger. So to find a suitable location to install a CCTV, just to monitor the worker, whether they wear the helmet, the vest. So it's a quite challenging task. So some of them, they will use the drone. So maybe every day at certain time, they fly the drone around the construction site to see whether their worker have to wear all this personal protective equipment or not. Okay.
So I think drone, it should be the very practical way. Because you just want to check the compliance on some of the workers around only. So you don't need to be always CCTV them, or 7 by 24, if let's say they work overnight. So I think drone is quite a practical way. The only thing is, when you fly the drone, the images, the video, are you able to get the correct data set? That is another issue.
Usually when we're dealing with the drone one, I think they will not do the processing live because it will consume a lot of the processing power. So I think they will fly the drone, record down the video, and then the video will be sent back to the headquarters, and they do the offline processing. So
maybe that's one of them.
If they want to do the live one, then actually the person who control the drone on the spot, they can issue a snapshot command to snapshot down all the scenario that the worker didn't wear the helmet already. So actually no need the AI at all. So one of the reasons they don't want that thing to be done is they want the person at the headquarters to supervise all this process. So to prevent something illegal happen, usually the one who fly the drone, maybe they will ask for something to prevent the worker at the site being fined. So if this thing done by the AI at the headquarters office, then it won't happen anymore. So today we'll show you a demo. So our colleague is at
construction site.
So he's already wearing the helmet.
No lah, we don't go to construction site. Hey, Amil. How are you, Amil? Hey. Okay.
So this one is, we only detect the helmet and the vest. So these are the two very I think it's a very important thing, especially the helmet. The helmet can save your life.
Wow. Well, this is 100% compliant.
Yeah.
Are you able to take out the vest, Amil? Oh, I can't hear. Oh, is it my this thing is are you able to take out the vest?
Yeah.
Sorry, got special requests like that. Oh, okay. Take it out, take it off. Just leave your helmet around. Yeah, okay. Okay,
So actually this one, the AI model we train is only focusing to detect the helmet and the vest. So if the person is not wearing all these things, nothing will be detected. So this one is just our first part. So coming, we will have second part, maybe next week or next 2 weeks. We will show you. So if the person is not wearing the helmet or the vest, the AI will draw another detection box telling you that one is
I see.
not compliance.
Okay. Amil, got one last request. Can you put up a different color of your helmet? Sorry to have such yes. Oh, okay. So I just want to ask, this is 0.879, that means it's accuracy, is it?
That one is the
confidence level.
Confidence, how AI say that one is the helmet.
So we can have a 90% confidence, you know, of course with a better data set or more data set will increase the confidence, the confidence level. That's part is the one of the AI, Okay.
To deploy this AI at the construction site, we have another challenge. Later I will show you another video where this AI might fail. So we not always show things that is 100% success.
This is a Sembang AIoT. So we just Sembang.
I will show you the reality.
Okay.
Where the AI might fail. So now, okay. Share the.
Thank you, Amil.
Okay, so this is a video we get from YouTube. We download from YouTube and then we tested with our AI model. So at the beginning, you see there's no detection at all. So even this guy is wearing a helmet, the AI failed to detect it. And then their vest is a little bit different from our data set because their vest is without the shining strip one.
Okay.
The one that can reflect the light.
Sometimes it's old already, the color faded. These are all the challenges.
So this kind of thing, and actually this one is taken from a drone, and this thing never appeared in our training data set.
Okay.
So you can see, okay, but for this one, because the helmet is very large, so the AI is able to detect it.
Okay.
Now we continue move. Okay. For this guy, it's still able to detect the guy. Then for this one, it detects some of it.
And some of them, it doesn't. Some of them is not detected. Right?
And then the confidence level also quite low, 0.62 only. So the ideal one usually is up to 0.8.
This is very far.
This is also considered far already. But the most important thing is this kind of camera will never appear in our training data set. Our training data set we get from it's an open source data set, and around 21K images. But we already go through the data set. They don't have this kind of view for the drone one. So whether it can detect it or not is depend on luck already in this case.
Okay.
So, okay. So in order to overcome this problem, so we need more data set on this kind of camera view. So if possible, if we can able to get those video footage from the drone, then that will be better. But also, we need some time to label all the helmet, the vest. And this one also depends because this one is at the overseas country. So their vest is different from the Malaysia one. So it depends on where you're going to deploy this AI model, whether it's in Malaysia or at overseas country. So we need to find out.
Okay. So that's all.
Yeah, that's all.
Okay, thank you, Ganong. So yeah, we don't only showing you good stuff, but we show you some
reality.
The reality in terms of AI. Of course, coming to IoT also, you have a different set of reality. Yeah, but since IoT is much more matured, everything is more predictable. That's why it's with the combination of IoT and AI data, you can do more things. That's why it's called AIoT. And then you can see our this tagline. You are ExomTech is always your best AIoT partner. That is something that we want to achieve. Yeah, of course. Thank for watching. Thank you for watching again. For some of those who are just following us today. So this sharing session that I would want to share is more on because last week I was talking about some temperature, temperature sensor, because this temperature is one of the key, component or key ingredients or parameter that exists in most of the industry, especially the manufacturing side. So this round, I'll pull up some of the pressure, in terms of a pressure sensor. What are the pressure sensor available? And then how can this be used, or how can be the step or to some of our IoT device, and also how you can share it across, or you can host the data for other people to use. Yeah. So for this case, I will have some simple slide here, just show to you. Yeah, this is a part 2. Yeah. So I just able to just click it. Oh, I have to just come here. So of course, last week we talked about AIoT. What is this AIoT? So IoT again is about connectivity, and AI is talking about computation, simulation, things like that. And then these two of them allow you to achieve your objective anywhere, anytime, anywhere. Any data, anytime, or anywhere. Yeah. So I was talking about this Tai Chi, in the last session also. When you have a yin and yang. If those people who study the Chinese philosophy before, of course, this is not a religion class. I just want to interpret this one. IoT is always on the yang side, on the positive side, and then the AI is always on the yin side, because it's doing things, quietly, doing computation. But IoT is you have to connect to many people. This is yin and yang in the Chinese philosophy. Yeah. So of course, when AI meet IoT, you have a Optimus robot transformer, popping out, and then that's where all the digital transformation happened. That was the last session. Of course, coming to the sensors this week, we have sensors. This pressure sensor. Where are those things appear? For some of you who are not in that industrial before, you have a boiler, creating some steam. Of course, need to know the temperature, also the pressure. Pressure is one of them. And then if you are doing some plastic injection process, some injection molding process, pressure is also one part which is also very important. That's why pressure is one of the process parameter, which is very important. Of course, many other food and beverage industry, they have this pipeline. You have to have all kind of what you call this pressure sensor around, plus some pump house, and water tank. Now, those water tank, I would explain to you how this pressure can use to measure the height or the level of the water or liquid in the tank. And of course, the gauge, analog gauge. Analog gauge also if you watch this previous slide also, analog gauge, we use AI camera to read the reading, and then publish to the cloud. That is also one of them. So basically, in terms of pressure, there are quite numbers, these are all, whether or not temperature or pressure, these two things actually come from very physics theory and physics concept, in what you call the physics theory, basically. All the very practical applied physics theory. For pressure, basically, you have two. I just want to touch two of them largely used in the industry. One of them is the piezoelectric pressure. Piezoelectric is when two material. No, piezoelectric is like those crystal type of material. When two sides, when you are compressing it or you put tension to it, so the electron the charges will start varying. So it can create a potential difference across the electronic circuits. This is one of the piezoelectric sensors. And then you also have, in fact, one of the very commonly used sensors is the what they call a strain. Strain. When you pull something, there is a strain. When you press something, there is a strain. This called strain gauge. Strain gauge, usually when you want to measure it electronically, you have to connect to usually a bridge circuit. If you studied in the electronics before, a bridge circuit is like what? Like a triangle, not like a triangle, it's a square, but it's a rotated triangle. So by using you see on the right hand side, this is basically a bridge circuit. And then you have an excitation voltage there. So you can actually, based on the pressure or strain onto the material will change state. Internally, it will give you different kind of resistance. So it will give you the potential difference, that correlate to the tension that you apply. This is how electronically it can be transferred. Of course, talking about IoT, these are the low level things that is happening, which I think it's good to get to know a bit of the concept. This is thing because when you come to IoT world, you see this morning when I talked to the other person, one of the clients, so he said, how can I measure the sound level? Sound level also people want to measure. Of course, I think in the environment, sometimes they want to know, they want to measure, and they want to make sure the acoustic level, is at a certain level, so that it won't be creating, the tension to your ear or something like that. That is also another thing that people is looking. So that's why understanding the concept behind, then you can apply it, or you can want to do, you want to use which sensor, or choosing the sensor is becoming more more easier. So okay, so in the center there is a kind of pressure, a differential pressure, which is very largely used in waterworks, in the water pipeline. When you create a different potential pressure differences, then you can also measure the flow of the water or liquid inside. This is also a different pressure is also very commonly used in the industry. So okay, there is one thing maybe I want to ask Ken Leong. Do you know what is this? Do you know what is this? What is TPMS? Maybe I ask the audience, what is TPMS? Don't know.
First time see this diagram.
Okay, so the TPMS is basically a tire pressure monitoring system. So you see, when this is also very interesting physics theory where you use a strain and also piezoelectric, partly, depends on what kind of a thing that you are measuring. In the tire, you have this so-called tire monitoring system. There is something. So inside there is a vacuum. It's giving you a vacuum. So they are using this what we call the pressure. It's called what you can see here. It's called. This part is actually measuring the atmospheric this pressure yeah. So it's called. It's kind of semiconductor thing that you can apply to this one. It can be a piezoelectric, and it can be also a strain. You can see the middle level here. There's a silicon strain resistant. Same thing. They connect to a kind of bridge circuit. Then it gives you a kind of voltage, or voltage that it will give you those reading that you are looking for. Same thing for this part. You use barometer. This is a semiconductor kind of barometer, or it's called micro electromechanical sensors, which allow you to give those atmospheric. When you bring up to the hill, when you go up to the hill, the pressure will become what?
Drop.
The pressure drop. Why the pressure drop?
Why pressure drop? Because less gas over there.
Less gas. I mean, our air molecule, has become lesser, so the pressure drop. These are all physics theory, yeah. So of course, in the real life, in the real industrial application, you have this weather sensor. Weather sensor inside this atmospheric. Other than gases, today we are not talking about gases sensors, but atmospheric. This part you are able to. You are able to use this, to measure what? You can use this, what we call our IoT gateway, this 4G gateway routers, you feed those bus data, you are able to publish things to the cloud. Yeah. So via MQTT. This is one part of it. Yeah. So of course, in a very generic way, one of the pressure sensor or strain that being used in related to a human being, what is that? Can you do a guess?
To measure our weight.
Weight, yeah. So when you want to measure the weight, also there is a strain inside. So you stand on it, so you can feed those data. This is how those weigh scale, weigh indicator, how they design that. They tap onto this. Also a bridge circuit. When you apply the sensor to it, then it will give you the correct the reading. For this case, you can use a strain gauge, a signal conditioner, which because milliwatt thing is not easy to measure. Yeah, milliwatt. If you want to measure milliwatt, you have to have a very clean environment, because this milliwatt is very easily interrupted or interfere by the surrounding. Yeah. So when you use a strain gauge, when you use a strain gauge, you can convert to 4 to 20 milliamp data. That part is allowing you to feed the data to the what you call some related modules, I/O modules. Then you are able to same thing, feed it to the gateway and also share it to the cloud. And also you can also host the data, host the data by providing API for people to connect to it. This part is a IoT integration, yeah. So, and also OPCUA, yeah. OPCUA is also one of the, of course, cloud publishing to the cloud is already covered in the previous slide. So talking about that, next week I'm going to share some of the way how you can construct OPCUA, hosting some temperature data, or even a pressure data, let's say, available. Yeah. So next week, I'm going to touch about that. So that is basically my sharing this for this week. But I just want to summarize everything, you know. See, what Ken Leong just now, he touches on the data set, you know, in order to get that kind of accuracy, data set become very, very important. Same thing like IoT, you know, when you want to measure certain things, the physical or the physical layer or the physics part of it, when you want to do measurement, you have to choose a very right tools, or what we call, it's the right tools, yeah, you right method. You know, for example, like, you know, you can use a strain gauge to do that. You can use piezoelectric way to do that. You know, depends on accuracy, stability, and so on. These are the areas where you have to, you have to analyze and which one is the best to use. So same thing, you see, IoT and AI both having the same fundamental where the source is very, very important. Yeah, if you get the source wrongly, you know, you're just like garbage in, it will give you garbage, you know, it's giving something that is not meaningful at all. Yeah. So that is the part that I want to share in this session. But I just want to open up to any of you. If let's say you have any question, you know, any comment, you can also type it in. Of course, we want to hear more comment from you so that to improve some of the sharing that we have. Yeah. So Ken Leong, do you have any other thing that you want to discuss about?
No more. And then I think for next week, I haven't figured out what to say yet.
Okay, doesn't matter. We are really we are not doing this sharing for earning. But very important thing, if let's say you want to learn something about AI and IoT, we have this 2-hour workshop still on. You know, you can still find some of it. Do we have a QR code for people to sign in? It's a free, completely free 2 hours workshop that talk about IoT and AI, and then you have some hands-on experience, you know, on the AI in our lab. Yeah. Do we have any things that we can share the QR code? If no, you can always go down to our link below. We will provide you a link for you to get you signed up to get to know about this thing, and then it's entirely free of charge. Yeah. So do we have? Yeah. So maybe we share to you. Yeah, we've shared to you. This is a link that you can sign up, and then when there is this workshop going on, then we will call you. You can scan in the QR code here. Okay. Yeah. So with that, we thank you very much for watching again, and wish you a happy weekend, because we had every Friday, you know, about 4:30. Sometimes we open the live. I wish you good day and happy weekend. The most important thing is we always innovate, we always apply, and we share and we train. See you again. Bye-bye.